Hi friends, welcome to this video on ggplot2. My name is Sonila. This is the fourth video in the series. If you haven't watched the previous three videos, please go ahead and watch them. In this video, we will focus on colors. Colors play a very important role in data visualization. They help to enhance our plots. They add more meaning without the use of further words or phrases and descriptions. And if we use the colors wisely in our plot, they can make our plots very useful and also make them look professional and add more value to whosoever is going to use that plot in future. So in ggplot2 there are a number of functions which help us to visualize our data using colors. So we will look at those functions and we will look at also some code. So if you are familiar with statistics, then there are two main categories of data. One is continuous and the other one is discrete. So in ggplot2, we have separate set of functions if we want to use colors with a continuous type of data, or if we want to use colors with a discrete type of data. So for continuous data, these are the functions, and it is pretty easy to remember because all of them have the word gradient in it. And that's because whenever we are visualizing continuous data, the colors are in the form of a gradient. And so we have these functions which have the word gradient in it and help us to remember what functions are used to display continuous data. These are some plots which I created using ggplot2 and those gradient functions, and you can see how the gradient is represented here with a gradual change in the color from from a lighter scale to a darker scale, or from one color to another color. And then we have these other functions which are used for discrete data. The one I use the most is the last one, scale fill manual. It allows me to manually give any color, any shade of color that I want to use on my plot. So it offers a lot of flexibility. However, the other ones can also be useful, but you have to take a decision based on your requirement, which kind of function best works for you, right? And then these are some discrete plots. We know that categorical discrete data can be displayed with the help of bar charts. So these are some bar charts which show discrete data, and there are colors which are used to represent each category of the discrete data. And we can use a grayscale, or we can use colors. Once again, the decision is up to the person who is doing the visualization to choose the colors wisely. So in the code that we will see, there are some functions. One of them is called the geom raster. So this function helps us to create a visual in which the data is displayed in the forms of tiles. So just like we have geom bars where our data is displayed in the form of bar, or we have scatter plot, geom point, where we use points or dots to display our data. So in the same way, if we are using tiles to represent our data, then we can use this function geom underscore raster. Then there is scale underscore x underscore continuous and y underscore continuous. These are used to show continuous x and y axis data. All right, so I think we are now ready to go and look at some code and see how these functions can be used. So here I'm on R, and the data that I'm going to use is called the faithful data. It is pre-built in R. And obviously we will use our ggplot2 library. And so let's take a look at our data set. Okay, so this is not a big data set. There are 5,625 rows in it, and there are 3 columns in it, and this is eruptions as in volcanic eruption data. And so there are three columns, all of them are numeric data: eruptions, weighting, and density. And here is the first piece of code which is going to be constant, and then we will be using each of the functions that we saw on this code to then visualize and see and compare how the addition of different kinds of functions results in a different look of the plot, right? So in this part of the code, I'm just defining using ggplot2 what's my data set, which variable will be my x-axis variable, which variable will be my y-axis variable, and I'm saying fill equals to density. So my three columns here, eruption and weighting and density, are used. Weighting is used as my x-axis, eruption is my y-axis, and density is my fill. So what I'm saying is, when you're filling my plot with colors, use this density data for setting the color. And density, as you can see, it's on a continuous scale, right? And then I'm using geom raster to show my data in the form of tiles. And then I'm also saying scale x continuous and y continuous, because I want to show my data in a continuous format. And then I have a argument here called expand, which allows me to add padding between the plot and the axis. Now here it is 0, so there will be no padding, but if you want to add, you can go ahead and do that. And then finally we have here the theme function, which we looked at in the previous video, so you can go ahead and take a look if you don't know what are themes. So I'm just inputting this much of the code into this erupt variable. So once I do that, then I can just use this erupt variable and then add the function that I want to use for displaying my density variable as a color. And then if I use my first function that we saw, which is just the scale underscore fill underscore gradient, and I give low equals to gray and high equals to black, this is the plot that I'm getting. So basically it is giving a gray color to the lowest data points, and then it is slowly gradually increasing the deepness of the colors till it gives the highest highest value of density, the complete black color, right? So as density grows from low to high, the colors is assigned to it low to high. So the areas here which are light gray in color, they are the low points, and the areas which are dark in color, they are of high density. So that's how this plot, we can interpret this plot. Now if I want to add also a midpoint to my graph, not the low and the high only, but I also want to show the middle point of my graph, so I can also do that. And in that case I will use the other function, which is scale underscore fill underscore gradient 2, and I have to define my midpoint also, which in this case I'm giving the mean density as my midpoint. And then along with low and high, I also will be giving the color for my mid value. Okay, and I'm saying that take midpoint as mid, which is the mean value. And I'm once again using my constant code erupt, and I'm just adding this new function and arguments to it. So if I do that, so this is the graph that I'm getting. So it is kind of this the opposite of the previous graph, because there the high density was black and here the high density is white. So that's why these portions are looking white. And then if you see that my mid color is gray and my low color is black, but there's actually nothing black on this graph. So we can interpret it as that my data, it actually contains a lot of lower values as compared to a lot of higher values. So that's why my mean is towards the lower end of the color scale, uh, and that's why the middle portions are all gray. So there is nothing that that there is a very low point and a very high point in the density, and so there is an exact like a middle point. It's not a symmetric kind of a data, it's kind of skewed more towards the lower end. So that's why my mean is more towards the lower end, and that's why there is a lot of gray, but there is not any black color on the graph. So we can interpret it in that way. So even without using any words, if somebody looks at this graph, they might be able to interpret how the data is. And then finally, we have erupt plus the scale fill gradient n function here. So now with this function, we can use more colors, and the function that I have, sorry, the package here is color space, and that are a lot of functions within it, like heat underscore HCl, diverge underscore HCl, and then this is another function called terrain dot color. So these are different functions and different packages that can be used along with these functions to give us different types of colors on our continuous scale data. So if I run the first one, I get this kind of plot, and then if I run the second one, I get a different combination. It's like a heat map kind of a thing. And then if I do diverge, then I get a different type of color, right? So if you have worked with Tableau, there also we have diverging colors, and also these are kind of similar to those options. So a lot of options, but it's just dependent on the person who is building all these plots to wisely use them. So don't go crazy and use these options where it's not really needed. Be very careful, and don't use way too much complications if it's not really needed. But I'm pretty sure that these graphs will come useful. But again, if you are maybe dealing with eruption data, volcanic eruption data, this might be a great way to visualize where the density was high or where the density was low. So it's dependent on the data as to what kind of functions you should use. Now coming to the bar graph that we saw, it's just a very simple data frame here. It just has like month and value. So we have 4 months, and then we just have some values associated with it. So if we see, it just looks like this very small data set. And as usual, I'm first defining the constant part of the plot. I'm calling it bars, and very simple, just giving the data set name, the x-axis, y-axis, and in this case I'm saying fill is equal to month. So that's the variable that based on which colors will be assigned to the bars. And then the remaining, I think, is pretty self-explanatory. So now we will look at the functions here. So the first function is scale underscore fill underscore hue. Now when I use this function, I'm not actually inputting any colors here. The colors are coming by default. The thing I'm changing is this function, this value c equals to 50, or c equals to 100, or c equals to 1000. And C stands for chroma. And I mean, I don't really know what it means, but maybe people who work with photographs and visualizations of other things, they might be able to interpret what they are. But you will understand when you see the graph how it works. So this is how the graph looks like when I'm just using C equals to 50. So now see what happens when I use C equals to 100. So see, the graph became much more brighter in the shades, isn't it? So here, this is the first graph, and this is the second graph. You see how it became more bright. So if I use C equals to 1000 now, it became even more brighter, very, very defined bright colors. So this this is the first graph where C equals to 50. This is the second graph where C equals to 100. And this is the third graph where C equals to 1000. But I'm only changing the brightness. I'm not really assigning these colors. Like I have not anywhere, if you see, not here or here, I have not defined any color. So the colors are coming on their own by ggplot2. So less control, but still you can do some, changes to how the colors look. This is another option where instead of C we have H, and H stands for hue. This is a word that I have seen on those apps where we can enhance our photographs. So if I use the H argument, in that case, I'm getting a different combination of colors. Now internally I don't know how these all these color combinations are working, uh, but if you want to use them, then go ahead and explore further. The next function is scale underscore fill underscore brewer, and we have seen this function in a previous video, and when we use this function we use this argument called palette, and then we give palette equals to a particular palette name. And there are a lot of palettes where you can look them up on the internet, and you can see which one works for you. So if I use this palette set 1, so as you can see I have not defined this this particular palette. I'm just using it to show you how it works. But you know with different palettes I'm getting with the set 1 palette, this is how the colors were looking on my plot. And then when I use the accent palette, this is how it is looking, right? So different options. And then scale fill gray, so this one gives me plots which are on the gray scale. So if I just use a gray, this is how my plot looks like. But if I use gray and I pass arguments where start equals to 0.5 and end equals to 1, see how that looks like. So basically it is assigning the last bar white color. So as we increase it, it becomes lighter and lighter, and it at 1 it assigns the white color. And if I do start equals to 0, then it assigns the pure darkest black color, right? So once again, lot of options. It's up to you how you use it. I think the grayscale is a great color to use. It looks very professional. You can enhance this plot, you can change the background, you can use the theme function to make more professional looking graphs, but definitely an option you should work with. And then finally the scale fill manual, the one that I use the most. And here as you can see I'm able to give exact shade of colors with the help of hexadecimal codes. So that's why it is so much more flexible. So I have 4 bars, so I have given 4 different color shades here, and if I run this, then I can get this plot. And I kind of remember all these hexadecimal codes because these are the ASU, Arizona State University colors. So this is the maroon shade, this is the gold shade that I frequently use on my plots. So you may want to check what colors, what shades your organization uses, and you can use them in the scale fill manual function, and you can define them and use them in your plots. So yeah, so these are all the functions that you can use to visualize discrete data with the help of colors, and these are the ones that you use for visualizing continuous data with the help of different colors. So that was today's video, guys. It was all about colors on ggplot2. I suggest you go ahead and explore further what are the other options that are available for using colors on your plot. If you like this video, then give us a thumbs up, share it with your friends, and don't forget to subscribe to our channel and also follow us on Facebook. A lot of videos coming, guys, so stay tuned and have a great week ahead.